Hey guys, this is the video for the first day of notes for going over perimeter and area of rectangles, squares, parallelograms, triangles, all the shapes, but now they're going to be on a coordinate plane. So it's not just going to be some random shape that we're going to say, find the area, find the perimeter. You're going to have to see it on a coordinate plane. So if you're looking at your notes, you should be seeing that there's actual graphs all over the place, and that's what we're going to be using. You still got to know your formulas. So at the top of your notes, you should have that the area of a rectangle will be base times height, still with the perpendicular base and height. Area of a square is still the side length squared. The area of a parallelogram is still base times height. Those sides, the base and the height, still have to be perpendicular. Area of a circle is pi r squared, and the circumference of a circle is 2 pi r. Both of those r's standing for radius. You could also call it pi d if you'd prefer. And then the area of a triangle is base times height divided by 2. Again, make sure you have right angles for your base and your height. So looking at the first example, it's already graphed out for you. A lot of times graph paper will make this a little bit easier to go through. But the first part says, find the following in simplest radical form, and it just says AB. We've done this before where it just says find AB. We're wanting you to find the length of that segment. You have a couple options for how you could do it, one of which is just the Pythagorean theorem. If you're going to use the Pythagorean theorem, you need to draw in a right triangle. If it's not horizontal, if it's not vertical, you can't count it. So let's do a Pythagorean theorem for that slanted length. So fill in the right triangle, your rise and your run. And I see that I filled in a vertical distance of 1 and a horizontal distance of 4. Those will be the legs of your right triangle. We do not know the hypotenuse, so that's x. So 1 squared and 4 squared gets 1 plus 16. Summing those together gets 17. And that's not my answer. We need to still solve this for x. We're going to do the opposite of squaring, which is to square root both sides. We do need to check to make sure it's simplified, but 17 is a prime number. There are not going to be any pairs of numbers that can be pulled out front. So that just means the length of AB is the square root of 17. We're going to do the same thing now for side length BC. So I'm going to fill in the triangle so that I can see what would be the legs of the right triangle. We still don't know the hypotenuse of this one because it's slanted. We can count the legs. So I can see a horizontal leg of 2, a vertical leg of 7. Squaring 2 and 7 gets me 4 and 49. Adding 4 and 49 gets us 53. And when you square root both sides to solve for x, you cannot simplify 53 either. So we're just going to have that side length of BC is the square root of 53. We could have gotten both of those lengths with distance formula. However, the issue with that would be, it's not really an issue. It's just you might be making more work for yourself than necessary. Because right now, when we go to find the length of CD, when we go to draw in that right triangle, we're going to see that it's the exact same triangle we had for segment AB. There's a leg of 1 and there's a leg of 4. So there's no reason to rewrite this Pythagorean theorem again. It's the exact same answer. You're still going to get the square root of 17. If you notice that you've drawn the same right triangle in, you do not have to do the work again. I'm going to draw in the right triangle for segment DA, and when I count those legs, I see a leg of 2 and I see a leg of 7. And what do you know? We already did the Pythagorean theorem with a leg of 2 and a leg of 7. We know we're going to get the square root of 53. So we do end up with 2 sets of congruent sides. They are on opposite sides of the shape from each other. We've talked about a shape that has that property. It's a parallelogram. It has opposite sides congruent to each other. However, that's all we know right now. We don't know if it's possibly a rectangle. We do know it's not other shapes. But let's move on then to talking about the slopes. That's the whole reason that part B exists. You can't tell the difference between a parallelogram and a rectangle. You can't prove it without finding the slopes. So we're going to find the slope of all 4 sides. So I'm going to start with side length AB. Most of us, when we think slope, we think rise over run. So I see that I'm going from point A, I'm going up 1, which is a positive 1. And I'm going to the right 4, which is a positive 4. I've put a positive 1 over a positive 4, which should make sense. If you picture going from left to right, we should see that this is increasing, that it's going uphill. However, segment BC does look like it's going downhill, so we should expect a negative slope here. So let's actually check it. I see that from C, I could be going up 7, that's a positive. Then I'm going left 7, that's a negative. So positive 7 over negative 2, that's just one negative number. I can pull that negative to the front of my fraction. That would be the same thing as having negative 7 over positive 2. Because remember, 2 negatives would make a positive. We only have 1 negative here. So let's do the same thing for segment CD. I see that I would be going rising -1, I'm going down 1, and running -4 because we're going to the left. So if you rise a negative and run a negative, two negatives make a positive, which should make sense. That line looks, if you read left to right, it looks like we would be going uphill. It's a positive slope. DA looks like we're going downhill. I should expect a negative slope, so let's try it. I see that I'm going down 7, which is a negative number, going right 2, which is a positive number. -7/2 would then be the slopes. Now, once we have all these slopes and all these lengths, remember I was saying we're trying to figure out what shape it is. That's what part C asks us. But you cannot just say, well, yeah, it looks like a rectangle, or oh, it looks like a parallelogram. We want to know why you have proof of that. So we need to actually think about the properties of quadrilaterals that we, at some point in your life, hopefully were told. So for example, if you don't have any parallel sides, you have a kite. You do have two sets of congruent sides. They're consecutive sides. Then you have a trapezoid. These are the ones where we see, it's usually the top and the bottom. It does not have to be, but we usually see those sides are parallel, and then the other two pairs of sides are not parallel. If you have two pairs of parallel sides, you have some sort of parallelogram. Some parallelograms have right angles. We call those rectangles. It's just a more specific name. Some parallelograms have all sides congruent. That's a rhombus. If you merge a rectangle with a rhombus, if you merge the right angles with the congruent sides, that's what creates a square. A square is still a type of parallelogram. You just have a few more properties that also apply. So we have one of these shapes. We have some type of quadrilateral that was graphed on our paper. We need to know, do we have parallel sides? Do we have right angles? We need to know all these things. The only thing we know right now is we have two sets of congruent sides, and they're opposite from each other. So we do not have a trapezoid, we do not have a kite. We have some type of parallelogram. We don't have a rhombus because all four of those lengths, we had a root 17 and a root 53. Those are not the same length. But we could have a type of rectangle. We could have right angles, and we cannot answer that until we address how to prove that you have right angles. So we're going to skip down to example 2 for a second. If your side lengths are going to be perpendicular, if you're going to have right angles, their slopes will be opposite reciprocals. Opposite meaning one's a positive number, one's a negative number. Reciprocals mean if you flip over the number, that's how you create the other one. So 2/3 is a positive number, -3/2 is a negative number. Those are opposite reciprocals. Same thing for -5 and +1/5. They are reciprocals because 5/1 and 1/5, one of the numbers is negative, one of them is positive. Anytime you see slopes like that, you have a right angle in the picture. If your side lengths are going to be parallel, meaning they're sloped the exact same, they're never going to intersect, then your slopes have to be identical. They have to be the same. So if you find a slope of -2 and later see another slope of -2, that would mean that you have parallel side lengths in your shape. The only difference between a rectangle and a square is whether or not the figure has two pairs of congruent sides or 4 of the same side. We know that about squares. We know all 4 sides. But you need to check to see, do we have 2 pairs of congruent sides or do we have all 4? So let's go back to that shape. We do not have all 4 sides equal. We do not have a rhombus. That means we cannot have a square. It's possible we have a rectangle, and you don't know that until you check the slopes. I see a slope of 1/4, and then I see a slope of 1/4. Anytime you see the exact same slope, remember we just said that means you have parallel sides. Same thing for BC's slope being the same. That's the wrong slope. That should be over 2. Sorry. Anyway, BC and DA you had as the same slope. So that means that we do have 2 sets of parallel sides. We do have a parallelogram, which we already knew. However, it's just a parallelogram. It is not a rectangle. We do not have right angles. We have 2 sets of parallel sides, which I just said with the -7/2 and the 1/4. But we also have, I didn't even type that in. There it is. We also have opposite sides congruent. Again, I already said that. The figure is not a rectangle because there are no opposite reciprocal slopes. We had a 1/4, but there is no -4. We had a -7/2, but there was no +2/7. There are no right angles in this picture because of that. It is just a parallelogram. With a parallelogram, though, we can go ahead and find the perimeter of it. We find the perimeter by adding up all of our sides. And since we already found all 4 sides, we could try to add those. We need to look for like terms when I do that. So I see a 1 root 17 here and a 1 root 17 here. Remember, when you add like terms, they stay like terms. A puppy plus a puppy means you have two puppies. So Root 17 plus root 17 means we have 2 square root 17s. Root 53 plus root 53, we have 2 root 53s. You could also put that in your calculator and get a decimal approximation. It is about 22.8, but the exact answer cannot be combined anymore. Now we can find the area of parallelograms. It is base times height, but you have to have right angles. And in that picture, there were no easy right angles. It is theoretically possible, but it would take so much longer to find. We're not going to expect you to do it on a problem like that. We wouldn't ask of that. So while it is possible, we're just not going to get to it. So sorry, I know you're disappointed. Skip to example 4. I think it should be on the back side of your notes. We got points A, B, C, and D. I'm going to first think how I can find that length of AB. One option is the distance formula. If you prefer the distance formula absolutely all day long, it will not fail you. You just need to think, well, I'm going to be finding the distance from point A to point B, so I'm going to use those as my x values and use those as our y values. So the x's are -3 and 0. The y's are 0 and -3. Make sure you put subtraction signs between those values before you square them and then add them. Know how to put it in properly, or know how to evaluate it properly. You should never get a negative number under these radicals. We end up finding that under the square root is an 18. And if you simplify that, you will find pairs of numbers. You will find a 9 and a 2, and the 9 creates a 3 and a 3. This simplifies to 3 square root 2. So the distance from A to B is 3 root 2. So if you want to use the distance formula, nobody is going to stop you. You absolutely can. But remember, your other option is to graph it first, which might help you kind of come up with a guess of your shape. You should still be able to do it without the graph, though. And from there, we can use the Pythagorean theorem to find our distance. So if I draw on the right triangle that is formed by segment BC as the hypotenuse, we can see that there's a leg of 3 and a leg of 3. So if you do 3 squared plus 3 squared, you do 9 plus 9, you will get 18. And we just simplified the square root of 18. The square root of 18 turns into 3 root 2 again. So BC also has a length of 3 root 2. The nice thing about Pythagorean theorem is when you go to find segment CD, you will realize, oh, hey, look, that right triangle has a leg of 3 and a leg of 3. I don't need to do that work again. I know the answer is 3 root 2. Same thing for when you go to find segment DA. A leg of 3, a leg of 3, you still get 3 root 2. The distance formula will still get you all 3 root 2s. It's just a matter of another option for how to do this. So we have all of our side lengths. Let's find the slopes. I already have those rise over run values written in, so we're just going to count them. So if I am looking at segment AB, I would start at A. I'm going to go down 3, so I'm rising a negative number, and I'm running a positive 3. So a negative over a positive would reduce to just a -1. I'm going to do the same thing for BC. I see that I would be rising a negative amount because I'm going down 3, and I'm running a negative amount because I'm going left 3. Negative over a negative should give you a positive, which makes logical sense. We see that we are going uphill as we read left to right. That is a positive slope. If you start noticing, man, I got that wrong again, I keep messing up the positives and negatives, you can use the slope formula. There's nothing stopping you from doing that. You can still say, well, my rise has to do with my y values. My runs have to do with my x values, and you could calculate it that way. So if we're going to find the slope of segment CD, you could just say, well, the y values are 3 and 0, so I'm going to do 3 minus 0. My x values are 0 and 3, so I'm going to do 0 minus 3. Unlike distance formula where order technically doesn't matter, it definitely matters for slope, so be careful about that. So simplify, 3 over -3, simplify, you get -1. The slope of segment CD is -1. Check your answers to make sure they make sense. This does make sense that it is a negative slope. And the last one, segment AD, if you're going to use the slope formula, I see that the y values are 3 and 0. The x values are 0 and -3, but there should still be a subtraction sign in between them if you're going to use the formula. You end up with a 3 over a 3 because subtracting a negative is a positive. The slope of that segment is 1. So we have all our side lengths. We have all of our slopes. This shape, which I'm assuming you probably guessed, is a square. However, you have to have proof of that. The proof is not just that all your sides are congruent. That is a true statement. But that is also true for a rhombus. You need to have right angles, and the only way we prove right angles is with opposite reciprocal slopes. So I see here a -1 and a +1. Those are opposite reciprocals. 1 over 1 flips over and it's equal to 1 over 1. And I see a positive number and a negative number. The fact that you have consecutive